Have you ever stopped to think about what's hiding in plain sight? We're always told not to judge a book by its cover. But what if I told you that in science, sometimes the cover, or in this case, the color, tells you the entire story?
Okay, let's just dive right into it with a pretty fascinating question. How can the exact shade of a liquid in a tiny little vial tell you critical secrets about your own health? Things like how well your liver's working, or what your blood sugar is doing. It really sounds like magic, but I promise you, it is pure, unadulterated science.
It all starts right here, with a sample inside this special little tube called a cuvette. You're basically looking at the treasure chest where all the secrets are hidden, and we're gonna figure them out just by looking at its color.
Now, the core idea here is incredibly simple, something you probably already get. Just think about making iced tea. The more tea you use, the darker and stronger the tea gets, right? It's the exact same principle. A darker, more intense color just means there's more of whatever stuff we're looking for.
This whole technique actually has a formal name. It's called colorimetry. It's basically the science of measuring color, but with a really high-tech spin. We use a special machine to see exactly how much light a sample soaks up, and that number tells us what's inside.
So, how does this actually work on a scientific level? Well, to really get colorimetry, we first have to understand the rulebook, the fundamental law that explains how light behaves when it zips through a solution.
And that rulebook is called the Beer-Lambert Law. Now I know, it sounds a little intimidating, but the idea is actually super simple. It just says that the amount of light that gets absorbed is tied directly to two things: how much stuff is in the solution, that's its concentration, and how far the light has to travel through it. More stuff means more light gets absorbed. Simple as that.
And here's what it looks like as a math formula. Now don't worry, you don't have to be a math genius here. Just appreciate that this simple, kind of elegant equation is what lets scientists turn a light reading directly into a super precise measurement of concentration.
Okay, so that's the theory. But how do we put it into practice? How do we actually precisely measure the exact amount of light that gets soaked up by our little sample?
We use this really clever device, the colorimeter. It's an instrument that was designed for one specific job: to put the Beer-Lambert law to work. It shoots a controlled beam of light through our sample and then measures whatever makes it out the other side.
Let's follow a single beam of light on its journey, okay? First, a simple bulb creates white light. Then, a lens focuses that light into a nice, neat beam. Next, and this part's really important, it goes through a filter that only lets one specific color or wavelength of light pass through. That single-colored light then travels through our sample, where some of it gets absorbed. Finally, a detector on the other side called a photocell measures how much light actually made it through, and a computer instantly crunches that number into our final result.
So we have the machine, we have the theory. But, getting a measurement is one thing. Getting a correct measurement is what really matters, especially in science and medicine. So how do scientists make sure their results are totally accurate and trustworthy?
Well, it all comes down to a crucial two-step process called calibration. First, they use a blank solution, usually just pure water, to set the machine to 0. This basically tells the colorimeter, hey, ignore any tiny bits of color from the plastic tube or the water itself. Then they use a standard, that's a solution with a precisely known concentration, to create a benchmark. It's like checking your scale with a known weight to make sure it's accurate.
And beyond calibration, just good lab practice is absolutely key. I mean, always using clean, scratch-free cuvettes, because a single finger prick can throw everything off. It also means making sure there are no tiny air bubbles in the sample, using the right color filter for the right test, and just generally keeping the machine clean. It's these little details that make all the difference between a good result and a useless one.
Okay, let's take all this out of the lab for a second and see how it applies to the real world. Because this isn't just some neat scientific trick. This technique has a huge impact on our lives, especially when it comes to medicine.
So here's the magic link. In clinical labs, a ton of diagnostic tests are very cleverly designed to, you guessed it, produce a color. A specific enzyme in your blood, for instance, is made to react with something that creates a colored product. And the intensity of that color is directly linked to how active that enzyme is.
And just take a look at a few examples. A test for an enzyme called ALT turns red to check on your liver. An AST test also turns red, and it looks for signs of liver or heart problems. An ALP test turns yellow to screen for liver or bone disorders. By measuring these really simple colors, doctors get this incredibly powerful window into our health. And it doesn't even stop there. We're talking millions of these tests are run every single day, all around the globe.
They're used to measure blood glucose and cholesterol, to analyze proteins, to check hemoglobin, even to test the quality of our drinking water. This thing is a true workhorse of the modern lab, just quietly doing its job in hundreds of different ways.
Now, you might be thinking the colorimeter can't be the only tool that can do this. And you'd be right. There's a more advanced, more powerful cousin out there. So why is this simpler machine still so incredibly popular?
Let's do a quick comparison. The colorimeter uses simple filters, and it's limited to the colors we can see. Its big brother, the spectrophotometer, uses a super precise prism and can even see into ultraviolet light, so it's more sensitive. But look at that last line. Cost. Spectrophotometers are way, way more expensive, and that is a huge piece of the puzzle.
And that brings us right to the colorimeter's superpowers. It's simple to use, it's small, and it's incredibly cheap. For thousands and thousands of routine, everyday tests, it's quick, it's accurate, and it gives you exactly the information you need without all the extra cost and complexity.
Honestly, this quote just hits the nail on the head. In so many labs, the goal is exactly this: a simple, rapid, and cost-effective tool. For that day-in, day-out work where speed and reliability are king, the colorimeter is often the absolute perfect tool for the job. It's just a beautiful example of the power of simple, elegant design.
So, we end right back where we began. We've seen how measuring something as basic as color can unlock this incredible amount of information about our own bodies. It kind of leaves you wondering, doesn't it? If a simple color can tell us all this, what other profound, invisible secrets are just waiting to be revealed all around us if we only knew how to look?